Okay, so this is the take-home quiz, quiz 3.5, and this first video will be scenario 1. So an IQ test shows the scores follow a normal distribution with a mean of 100 and standard deviation of 15. So I'm going to go ahead and make a note of that. Mean of 100, standard deviation of 15. So that's our scenario, and this first video will be scenario 1, which is problems 1 through 9. It says find the z-scores associated with the middle 80% of the data. First off, it says z-scores. So even though the mean of the distribution is 100, standard deviation is 15, with the z-score, since it asks for a z-score, the mean is 0, the standard deviation is 1. And then they gave me an app. They gave me a percent. Since they gave me a percent, I know I'm working with the inverse norm. All right, so I'm working with an inverse norm, and my drawing is going to look like this. Mean is 0, and then we're looking for the middle 80%, so 0.80. So this is going to be my lower bound. This is my upper bound. And since it's the inverse norm, let me get my calculator ready. I guess I didn't have it. Second quit. So second vars, inverse norm, area, parenthesis, 1 minus 0.80, close parenthesis, divided by 2, mean is 0, standard deviation of 1. And we end up getting negative 1.28. So my lower bound, lower, equals negative 1.2815. We're going to do the first 4 digits. And then we need to go back and do the upper bound. All right. And by the way, this formula would have been 1 minus 0.80 divided by 2. Now we need to do the upper bound. And the upper bound is going to be the same thing, except it's going to be 1 minus 0.80 divided by 2 plus the 0.80. Mean is 0, standard deviation of 1. And again, it's going to be an inverse norm. So second vars, inverse norm. So I just need to come back and add the 0.8 to it. So the plus the 0.80. And I end up getting 1.2815. So my upper equals 1.2815. When you're inputting this into the document, we just want the negative 1.2815 and the 1.2815. No labels, no U, no L, just this number and just this number. That's what we need to see go in. All right, so that's what you put into the Google form. Then it says find the actual IQ scores associated with the middle 80%. So they gave us an app, so we know we're working with the inverse norm. So we're still working for the inverse norm. But now we're working with the actual values. The z-score, it's always mean of 0, standard deviation of 1. But up here, this problem has a mean of 100 and a standard deviation of 15. So if I'm drawing my picture, I'm going to draw it over here so I have a little more room. So now my mean is 100. And we have an upper, makes me a lower, and an upper, and this is going to be 0.80. So it's inverse norm. 1 minus 0.80 divided by 2, mean of 100, standard deviation was 15. So this is what I need to put in the calculator. Second quit, second vars, inverse norm, parenthesis, 1 minus 0.80, close parenthesis, divided by 2, mean of 100, standard deviation of 15. And this will get me my lower bound. And my lower bound is 80.776. So lower equals 80.7677. So that's that lower bound, and that makes sense because that 80.77 is below 100. Then I need to come back and rerun it, and my upper bound is also going to be inverse norm 1 minus 0.80 over 2 plus the 0.80 mean of 100, standard deviation of 15. So second vars, inverse norm, 1 minus 0.80 divided by 2 plus the 0.80, mean of 100, standard deviation of 15. And we get 119.2232. So my upper is 119.2232. And that makes sense because it's above 100. So we had a lower equals 80.7677. Please make sure you're only putting the numbers in the calculator. Be careful, into the Google form. This is a positive, all right? This is the positive number. So an IQ of 80.7677 and a 119.2232. Then it says find the z-scores associated with the lowest 15% of the data, all right? So they gave us a percent, so they gave us an app, all right? So this means I'm going to be working with an inverse norm. And it's a z-score. So this is a z-score. My mean is 0. My standard deviation is 1. This right here is 0.15. This goes to negative infinity. So we go with the calculator. Second vars, inverse norm. The area, and by the way, since this started from the left, because it was the lowest, so I could put an X, and 0.15 is below it. Since we started from the left, we can just put the percent in directly. We do not need to subtract. The 0.15, mean is 0, standard deviation of 1. That's what we should put in the calculator. So 0.15, mean is 0, standard deviation of 1. And we end up getting, our answer is negative 1.0364. So that's our z-score. And the part that I boxed is the only thing that should go into the calculator, into the Google form. The next one, find the actual IQ scores. Well, when we looked up here earlier, the actual was 115. All right, but they're wanting for the lowest 15%. So the only difference between this one and the last one is we need to change our mean to 100, and our standard deviation is going to be 15. All right, so our mean is going to be 100 and our standard deviation is going to be 15. Our area is still going to be 15%, so 0.15. And they said lowest 15%. So this is an X, this is below it. So we're starting at negative infinity. That's supposed to be a negative infinity sign. And since they gave you a percent anytime they give you an app, it's inverse norm. So we have 0.15, 100 is our mean, 15 is our standard deviation. So second vars, inverse norm, area is 0.15, our mean is 100, and our standard deviation is 15. And this becomes 84.4534. And please just truncate. So 84.4534. And it makes sense because our X value that we're looking for happens to be below 100. All right, so we're expecting a value below 100. The next one says calculate the upper 7%. All right, so I draw an X and 7% is on the right. That means I'm shading from the right. Right, so this means I'm shading from the right. And we're looking for a z-score. So mean is going to be 0 because it's a z-score. Mean is 0, standard deviation of 1. And we're looking for this value right here. All right. Now, please remember, the calculator works from left to right. And so if we shade from the right, we have to subtract. So what we're going to put into the calculator is the 0.93, which is 1 minus 0.07. All right. So since they gave us a percent, this is going to be an app. So this is going to be inverse norm. And we're going to put in 1 minus 0.07, or just plain old 0.93. That's fine too. Comma, mean is 0, standard deviation of 1. Second vars, inverse norm, 1 minus 0.07, mean is 0, standard deviation of 1. We should get a negative value because we're below 0. And the, oh, excuse me, no, we're not. We're above 0, so we get a positive z-score because we're over halfway. So this gives me a positive 1.4757 is what I got on the calculator. A positive 1.4757 is what I got on the calculator. And this is the value that I'll put into, this is the value I'll put into Google form. So second vars, inverse norm, and you could have used 1 minus 0.07 or just plain old 0.93, and we should get exactly the same thing, 1.4757. We had to subtract because we came from the right. So you subtract when you come from the right. Find the actual IQ. So now we're not working with the Z, we're working with the actual scores, which was a mean of 100 and a standard deviation of 15. So here's my 100. We have an upper 7%. So I draw the X, 7 is above it. So we're shading from the right. So this is 0.07. So I'm going to have to subtract, and I'm going to go 1 minus the 0.07. This gives me 0.93. We know that because they gave us an app, we're doing inverse norm. Which is going to be 1 minus the 0.07. Mean of 100, because it's the actual value, not a z-score. Standard deviation of 15. Second vars, inverse norm. Area, 1 minus the 0.07 or just the 0.93. Either one was fine. Mean of 100, standard deviation of 15, because we're working with the actual value. And we get an IQ of 122.13686. So what we're putting in the calculator, into the Google form, is 122.1368. 4 decimal places. Okay, and that makes sense because our value we know has to be above 100, and this is above 100. Find the z-score for the highest 1%. So it's a z-score, so our mean is going to be 0, our standard deviation is going to be 1. And they say the highest 1%. So I put an X, and high is going to be above. So we're going to be shading from the right. And since we're shading from the right, we know we're going to have to subtract. So this little area right here is 0.01. Be careful to make sure it's a 0.01. You have to move the decimal place 2 places. 1 minus that gives me an area of 0.99. I had to subtract because I'm shading from the right. Please don't forget that. That's probably one of the trickier things we're doing. If you're shading from the right, you must subtract. They gave you a percent, so they gave you one of the apps. So it's inverse norm. 1 minus the 0.01. Mean is 0. standard deviation of 1. Second vars, inverse norm, 1 minus 0.01 for the 1%. Oop, not 0.07, 0.01. Z-score, mean of 0, standard deviation of 1. And we end up getting 2.3263. Oops. Let me rerun all that. Second vars, inverse norm, 1 minus the 0.01, or you could have just put in 0.99. Mean is 0 for a z-score, 1 for the standard deviation. And we end up getting 2.3263. 2.3263. All right. The next one says calculate the actual test score for the highest 1%. So once again, we have a highest, so we put an X. This is above it, so we know we're going to be shading from the right. We know it's going to be an inverse norm because they gave us an app, so inverse norm. And we are working with the actual value, so it's mean of 100, standard deviation of 15. So drawing my picture, this is 100. We're looking for the 0.01, but please remember, because we're coming from the right, we have to subtract 1 minus 0.01 is just 0.99. So in the calculator, inverse norm, 0.99, or if you prefer, 1 minus 0.01, mean of 100, standard deviation of 15. Second vars, inverse norm, 0.99, mean of 100, standard deviation of 15. And we get 134.8952. 34.8952. Please always put in 4 decimal places if the calculator gives it to you. If it doesn't, put in as many as it gives it. Now, out of a population of 5,000, how many will have scored greater than 135? They did not give me an app. They didn't give me a percent. I'm probably going to be looking at a norm CDF. Now, I will tell you this particular problem is one of the most difficult. How many will score greater than a 135? So let's draw a picture. We know the mean of our distribution happens to be 100. We want to know how many scored above a 135. So mean is 100. Standard deviation is 15. Norm CDF, looking at the drawing, I'm going to say my lower bound is 135. My upper bound, it's going to go to positive infinity. My mean is 100. And my standard deviation happens to be 15. So let's go ahead and calculate that. So second vars, normal, CDF, lower bound, 135. Upper bound, loaded up with a bunch of 9s. Mean, 100. Standard deviation, 15. And I end up getting 0.0098. All right. So this equals 0.0098. But they didn't ask me for a probability, they asked me for how many. So here's what I need to do. This tells me I'm really looking for an expected value. So I need an expected value is the number times the probability. Well, how many people were there? There were 5,000. 5,000 times what I already have on the calculator, 0.0098. So I'm going to multiply that times 5,000. And it tells me that I'm going to get 49.0765. All right. So how many people? About 49. Now, if you put in 49.0765, you're going to get full credit. If you rounded and got the 49 on this, we'll probably get you full credit on that. But somewhere between 49 and 50 should be your answer. All right, so that concludes our first video. Our next video will be scenario 2 and 3.